Okay, so this is a guided walkthrough for the deploy machine on VulNyx. It is a low-level machine, and let's start our enumeration. Okay, so the first thing we want to do when we hack against a CTF box like this is we like to run the nmap command. The nmap command is going to let us know which ports are open on this particular server, and we run it with the following arguments over here. -T4 for very fast speed but not too fast, -VV for very verbose output, which means that the scan is going to give us output before it is finished. So it basically gives us information as it gets it. -P-, which is going to scan all of the ports on the system, as well as -S capital C and capital V. Capital C does common scripts against whatever services we find, and capital V gives us versioning information against whatever services we find via nmap. So let's run the command. So we see that it finds 3 ports open on the system. It finds port 8080, port 22, and port 80. So we see here that port 22 is running OpenSSH, and this is a particular version of the SSH protocol, and it's running with version 8.4. Port 80 is a web port which runs web servers, HTTP, and its reports running the Apache software with version 2.4.56. And port 8080 here is usually running an HTTP proxy. In this case, it reports running Apache Tomcat. So Apache Tomcat is, we'll talk a little bit more about Apache Tomcat in a little bit, but so what we're going to do is we're going to scan Apache Tomcat over here with Nikto. So Nikto is a web app vulnerability scanner, and so it's going to be able to determine a lot of low-hanging fruit vulnerabilities associated with web servers. In this case, we're scanning against the target on the Tomcat port, which is 8080. Okay, it says no banner received. Gets us some information. It didn't tell us that it was running Tomcat, strangely enough. It does tell us that it appears to be a default Apache Tomcat install. So one interesting thing about Nikto is that Nikto is very good at scanning for specific technologies on web servers, and Apache Tomcat is one of them. Because Apache Tomcat, I think Apache Tomcat used to be popular maybe 10 years ago, maybe 10 or 20 years ago, but it's not so popular anymore. So I guess because Apache Tomcat was popular, Nikto has a bunch of scanning functions that look at Apache Tomcat. So it says here under Manager HTML, a default account found for Tomcat Manager application at ID Tomcat password secret was found in Apache Tomcat. Okay, so we found default credentials for Apache Tomcat, which is username Tomcat, password secret over here. So I'm just going to copy this, and I'm going to try to access it manually over here. So first of all, let's talk a little bit about Apache Tomcat. Apache Tomcat is a Java-enabled web server software which allows Java servlets to be run on web pages. If a malicious user is able to gain admin-level access to a Tomcat server, then malicious Java code called war files can be deployed on the website. Okay, so let's demonstrate. So over here, we're going to go to the web server on the Tomcat port, which is 8080. Okay, if you're seeing this page via web browser, that means you've successfully set up Tomcat. So the Nikto scan reported that this endpoint over here, manager/html, this is where we're able to access the Tomcat manager application. So manager/html. So we're going to go over to manager HTML. It's going to ask us for a username and password. So in this case, the username is Tomcat, and the password is secret. The password is secret, which is spelled like this, S3CRET. Okay. After that, we click on Sign In, and we have access to the Tomcat Web Application Manager. So if we're able to access this page as the as an admin level user, we can upload and deploy malicious war files. So in this case, what we want to do is we want to deploy a malicious war file on the server that gets us reverse shell access. And we can do so by using the NSF Venom tool on Kali Linux. So over here, I'm going to use another tab. So this is the command we're going to use. So MSF Venom is a tool inside of Kali Linux where you can do all sorts of malicious things. In this case, what we're going to do is we're going to create a reverse shell Java file using this reverse shell payload over here, JSP shell reverse TCP. We're going to provide a listening host, which is our attacker machine, which is at this IP address. We're going to provide a listening port, which is 443, the one that I always use. We're going to specify a format, which is the war file, and an output file name, which is shell.war. So we're going to run that. And it's going to create the malicious file called shell.war that we can deploy on the Tomcat system. So we have the file here in our temp directory. Okay. We're going to go back to, okay, so before we go back and upload the file, what we're going to do is we're going to create a reverse shell listener. So over here, we're just going to create a netcat reverse shell listener on port 443. This is going to be able to catch any incoming reverse shells coming from the target system. Next, we're going to go over to the web application, and then we're going to upload a file. So war file to deploy. We're going to deploy directory located on server. War file to deploy. I think this is the section we want to use to upload the file. We're going to click on Browse, and then go to our temp directory where we created the file. We've got this shell.war file, which we're going to upload to the web server, and then click on the deploy button over here. Okay, so we now have a /shell endpoint on the system. When we access the /shell endpoint on the system, let me make this a little bit bigger. When we access the /shell endpoint on the system, it's going to run the code inside of the shell.war file that we created using NSF Venom, and that code is going to create a reverse shell connection to our attacker machine. So let's go ahead and do that. So in the address bar, so after the IP address, we're just going to go shell and then access that. So we see here that the page we access is blank, but when we go over to the reverse shell listener over here, it says we got a connection from this IP address, which is the target on this port over here. Okay, so let me take a look at what's going on. What we're going to do is we're going to try to, we got access to the server. If we type 2mi, it says we are the Tomcat user, which means we have broken into the web server. And when we break into a server, we have to change our voice and put our scary hacker voice on. So let me just load up my voice changer.
Hey everybody, it's that time. It's the scary hacker voice time. Whenever we break into a server, we have to put on our scary hacker voice and say, "We're in."
And then we go back to our normal voice. Okay, so the first thing we want to do is we want to upgrade our netcat shell. So netcat shells are notoriously less useful than regular SSH shells. So what we want to do is we want to locate the Python program to figure out how we can upgrade our shell. And we can upgrade our shell somewhat by using the Python 3 program. So I'm just going to do Python 3 -c, and then it's going to be import pty.spawn bin bash, and that's going to get us a slightly, oh no it doesn't, because I made a spelling error. Okay, let me do this one more time. Import pty.spawn bin bash. Okay. So we now have an upgraded shell over here because we used Python to spawn one over here. Great. And another interesting thing about the Tomcat program is Tomcat actually stores its credentials inside of a specific XML file, and the XML file is in the Tomcat 9 directory. So let's see, Tomcat 9 directory goes to etc Tomcat 9. So let's go over to the etc Tomcat 9 directory here. And in that directory, there's a specific file called tomcat-users.xml. So this file over here on Tomcat servers has the user credentials for the system. So tomcat users.xml. When we read this file, did I spell that incorrectly? Oh, tomcat users.xml. Okay. So we see here inside this XML file, it has all of the valid users for the Tomcat web page. So we see here that the default user is this one over here. It's Tomcat password secret, but there's another set of credentials in here as well. It says username SA and password is this right here, salala ! So if we take a look at the users on the system, we see that the SA user also exists on the system, so we can actually use this set of credentials to escalate our privileges and become the SA user. So we're going to go back to another tab here, and we're going to SSH as SA to this server. So the IP address is 61, okay. SA's password that we stole from the Tomcat users XML file is SALALA ! And now they're now logged in as the SA user. So luckily for us, this is an SSH shell, so we don't have to deal with the cruddy netcat Python shell that we're using earlier. Okay. So the next thing we need to do for privilege escalation is, let me demonstrate. So for privilege escalation on this box, we're going to use something called privileged web server process. So we notice in the processes list that the Tor user is running the web server software running on port 80, which only has the default Apache page. So if we go over, so there were two different web servers on this particular machine. there is the Tomcat one at port 8080, but there's another one at the default port, which is port 80, and it just has this Apache 2 Debian default page here. If we take a look at the processes running on the system, so it's ps aux, then we see that there's another user here named Tor that is running the Apache 2 server. So the Apache 2 server is the one that is running on port 80, and because this user is running the Apache 2 process, that means that if we use this particular web server to host a reverse shell file, then it's going to give us a reverse shell as the Tor user, which hopefully has more privileges than this SA user over here. Okay, so one other thing is required for this to work is that thing is we need to be able to write to the default web directory, which is var www.html. And we see here for this particular directory, there are full read and write privileges for everybody on the system. This is unusual, and this should not be allowed. So typically only the www data user should be able to write files to this directory, but because everybody can, we can actually create a malicious reverse shell file in this directory with the SA user. So let's do that. So we're just going to navigate over to that directory. So when we look at the permissions in the var www.html directory, which is the web root for the port 80 website, we see that there is public write access for that directory, which means that we can put malicious files there. So that means that we could write a reverse shell PHP file to the Tor user's web server and receive a reverse shell as the Tor user upon connection. So what we're going to do is we're going to write the reverse shell script in the Tor user's web server. So let's do that. First of all, I'm going to get a reverse shell file, and there's actually one on Kali Linux, which is located at this location right over here. So I'm just going to copy it. Actually, no. What I'm going to do is I'm going to read it. So I'm just going to read it. And I'm going to copy all the code. So I'm just going to go over here, copy all the code from the reverse shell file. And then I'm going to go to the tab where I have my SSH access. And we're in the var www.html directory, which is the web root for the web server on port 80. I'm going to use nano php reverse shell.php, and we're just going to write this file in the directory. I'm going to paste in all the code that I just got, and I'm going to change out a couple of variables. So I need to change out two variables with this particular reverse shell script. The first thing is to change out the IP address and then the port number. Okay, so now that this is all set up, I can save this. And now there's the index.html default page, and then there's the reverse shell.php page hosted on the web server. So all we need to do is set up our netcat listener again. And the netcat listener is going to be on port 443. Okay, so we're listening on that port. And then we're going to navigate to that page using our web browser. So our web browser is over here. So to activate the reverse shell, we're going to access the file that we just created, which is php reverse shell.php. So when we run that, we see that the web page hangs, which is a good indication that that the code is running. Then we go over to our netcat listener, and we see that we've received a reverse shell connection. When we ask who am I, it says we are the Tor user because the Tor user started the Apache server on port 80. Okay, so now all we need to do is elevate our privileges one last time. So to elevate our privileges one last time, first of all, I'm going to use Python C. Actually, I think it was Python 3. Which Python 3? And then Python 3 command imports pty.spawn bin bash. Okay. And let's explain the last step in privilege escalation on this system. So the last step for privilege escalation on this system is sudo ex. So ex is actually a text editor that is related to the Vi and Vim text editors. It's an earlier version of it, I think. If we have sudo access to ex, we can use the above command to open a root shell. So we just do sudo ex and then interrupt the program process with this command right here to open up a shell with the sh program. So it's sudo ex bang/bin/sh. So over here, we do sudo l to find out that the Tor user can run as root with no password user bin ex. And then we do sudo ex. And in the middle of running the program, we do bang/bin/sh, which is going to open up a root shell for us because we're running as sudo. When we ask who am I, we are now root. Let me see if I can. Who am I? We are root. Okay. So all we need to do is run all we need to do is run our redeem where we are now root.
What are you? I'm system root.
Okay, so we managed to become the root user. So the last thing we need to do is we need to read the root flag file to complete the exercise. So we can move into the root directory, and we see here there's the root.txt flag. If we weren't root, we wouldn't be able to access this directory or this file. So we're not going to read out the root.txt contents directly because the people at the VulNyx website don't want people who do videos or walkthroughs of their machines to leak out that information for these flags. So instead, I'm going to cat the root.txt file, and I'm going to redirect the output into a file called iReadRoot.txt. After that, we're going to do in MD5 some hash check and compare the two. So we see that these two files have the same file hash, which means they're effectively the same file, which means that we've read the root flag and we've finished the exercise. All right. Thank you very much, everybody, for watching. This is going to be a YouTube video, and we will see you next time.
Hey there, HackerFrogs! Are you enjoying this workshop? Learning new concepts and skills? If so, there's a way you can support the channel, and it's totally free. Just click on the subscribe button below the video. Also, click on the like button. And if you have questions or comments on this workshop, please leave them below the video. Thanks for listening. And now, back to our scheduled programming.